Hi guys, and welcome back. Let's go ahead and start building out a multi-node Kubernetes cluster using the kubeadm utility. Now, if you are brand new to kubeadm, then I would encourage you to go watch my other skill where we introduce the kubeadm utility, because that's going to cover some of the basics about how to create a single node cluster. But in this video, we're actually going to create a in this skill, we're going to create a multi-node cluster so that we have more than one master node in our Kubernetes cluster, and we'll be able to load balance the communication to those master nodes by using a cloud-based load balancer. So for starters, let's go ahead and switch over to our browser here. And there's a really good document out on the Kubernetes documentation called Creating Highly Available Clusters with kubeadm. Now, if you are brand new to Kubernetes, this documentation can be a little bit confusing. In fact, it kind of assumes that you already know how to install kubeadm, which is a separate document here. And it also kind of assumes that you know how to create a cluster with kubeadm as well. And this is why it's really important to go watch my other skill that talks about how to create a single node cluster. But we're going to be incorporating these documents into the Creating Highly Available Clusters with kubeadm document in order to create this complete solution. Now, if we scroll down a little bit here, you'll see that we have these two different models here. We have the stacked etcd model and the external etcd model. And that kind of refers back to what I was discussing in the previous video, where when you have a Kubernetes master node, by default, the etcd state store will be replicated on each node within the cluster. Whoops, let me bring that to the front right here. And if you have etcd running on each of the nodes within the cluster, then that is what we would consider to be a stacked etcd deployment. Now, if you would prefer to have etcd running as an external service, then that's where you would take a look at the documentation for connecting to an external etcd state store instead. But because the default configuration is to have etcd be on each node within the cluster, that is the approach that we're going to take for this particular skill. So each of the master nodes that we spin up is going to have its own instance of the etcd service. All right, so one of the things that we're going to need to do for starters is to spin up a couple of virtual machines in the cloud for us to start building with. And I'm going to be using Amazon Web Services, but you could essentially follow these directions for other cloud vendors as well, because essentially at the end of the day, all we're doing is spinning up a couple of Linux virtual machines on the same software-defined network and ensuring that they can communicate with each other. So let's head over to our AWS Management Console. Let me fire up a new tab here, and we'll go over to the AWS Management Console here. And let me just get logged in here really quick. And now we'll head over to the EC2 service, and we'll just create a couple of virtual machines. So I've already got a couple of VMs running here, but we're going to kind of create this from scratch. So I'm going to create two different virtual machines so we can have a master node 01 and a master node 02. Now, in most production environments, you're actually going to want to have at least 3 nodes or have an odd number of nodes. So if one of the nodes were to go offline, the wrapped consensus algorithm would be able to find a proper secondary node to kind of take over in order to ensure that your cluster continues to run. So let's go ahead and choose launch instances here, and then I'll find the Ubuntu Linux operating system image right here. And then I'm going to choose the T3 medium instance type here, which has 2 virtual CPUs and 4 gigs of memory. And then on the instance details here, I'll choose to request spot instances, and I'll choose persistent request, and I'll just have the interruption behavior set to stop. And I'm going to request 2 instances so that we can have 2 different nodes in our cluster here. And then I'm going to go ahead and just leave the default settings for my VPC here. that I can basically deploy them into a public subnet and then SSH into them. You can also choose a specific subnet, and I might actually do that because I do actually have a subnet here that I don't want to accidentally have them be deployed into. So I'm just going to choose the US West 2A availability zone here, and that will automatically assign a public IPv4 address to these nodes. Probably want to bump up the storage a little bit too, because some of the container images do need to be downloaded in order to spin up a cluster. So I'll just choose 15 gigs of storage. And then I need to make sure that I choose a security group here that has inbound access on TCP port 22 so that we can SSH into these virtual machines and manage them. So I'll go ahead and just launch these, and we'll give them a couple of seconds to spin up. And then once those instances spin up, we can start to install the necessary software onto them. So I'm going to come over to the Instances tab here, and I'm just going to choose one of these and name it, let's say, CBT Master 01. And then I'll name the other one here, CBT Master 02. So now we have some friendly names to identify each of these nodes by. I'm going to grab the public IPv4 address for the CBT Master 01 node, and let's fire up a terminal session here, and we'll just get SSH'd into it. So we'll do an SSH command and get logged in, and then I'll fire up another terminal here, and we'll SSH into the second node as well. So let me find the IP address for the second node and SSH into that one as well. And everything looks good here. So one of the things that I'll do is actually just rename these nodes. So by default, they just have kind of the IP address as their host name, but that's not very user-friendly. So let's go ahead and just rename these nodes. I'll do sudo vim etc/hostname, and we'll go ahead and name this one, let's say CBT Master 01, and we'll do a save on that, and we'll go ahead and reboot him. And then over here on the right-hand side, we'll do sudo vim etc hostname, and we'll name this one CBT Master 02, and we'll save that file, and we'll do a sudo reboot on him as well. And once both of these nodes come back online, they should have a new name. All right, so as you can see, both nodes have been successfully renamed here, and so now we can start configuring these nodes to install the necessary components like kubeadm in order to establish a new cluster and get things all set up. So we'll do that in the next video. I hope this has been informative for you, and I'd like to thank you for viewing.